Our next phase is mute positioning. And mute positioning, we're actually setting the safe, unsafe zone of the safety system. The way the machine activates is as the ram is coming down, it travels fast until it gets to the slow speed. Once it does that transition to slow speed, the ACAS starts to set a timers. Those timers time out at 0.7 of a second, very quickly. Once they time out, then it'll do a distance check of 4 millimeters. With the ACAS 3, it'll be 2 millimeters. Once the timing sequence has expired and the distance check has accomplished its goal, it will mute out, continue right on through the bend. In order for it to do this, we have to set mute positioning. So, what we want to see is we want to see the transition point high enough to initiate the timing sequence and low enough to where it mutes out just above the top edge of the material. The way this is accomplished is by mute positioning, or nicknamed the nickel test. If you take one nickel, it's right at 1/16 of an inch. You place one nickel on top of another, you have right at 1/8 of an inch, hence the nickel test. Or you can take a scrap piece of material equal to 1/8 of an inch. Basically, you want to set the speed transition point to where when the ram is coming down, and if you notice, I set the part that I'm setting the system up with over to the side so I don't bend it. So this way I can reuse it over and over again to set my mute positioning. So I bring the ram down, it goes into a slow speed, it mutes out, travels right on through with the material in place. Speed change, distance check, mutes out. If we take a piece of material equal to 1/8 of an inch, place on top of the material on the bend line, we bring the ram down again, it stops. Lift our foot up, press it again, we can force right on through the bend. Remember, first hit's an activation, second hit's an override. So, this is telling us that this system is actually set up properly. We take the scrap piece of material away, goes through non-stop. So as a recap on the mute positioning test, if it comes down and the lasers see the top edge of the material and stops, then that's a no-go. You want it to come down, go into a speed change, and mute out just above the top edge of the material. If the lasers come down and see the material and the scrap on top, and it continues on through the bend, that's also a no-go. That means the speed transition point is too far away from the top edge of material. So if it stops with the material, speed change needs to go away from the material. If it continues with the material and the stop test block, then that means the speed change needs to go closer to the material. The way that you would change your speed change, some machines have a manual adjustment on the side where you would actually manually adjust it. Others will have programming. On this particular machine, you have ram speed. On the AutoBend Herco AutoBend 7, it will say ram speed. Although many misconceive that as the speed of the ram, it's actually the speed transition point of the ram. So ram speed will set the position of the transition of speed from fast to slow. Again, material goes through non-stop. Scrap on top comes down and stops. If we want to force through like it's wavy material, lift your foot up, press it again, it will force right on through. And if you notice, when we force it, we see the light come on solid.